Structural philosophy is the designer's rulebook. It decides weight, cost, how easy the airplane is to build and fix, and how it behaves in flight. Narrow bodies optimize for quick turns and high production rates. Wide bodies optimize for cabin volume, long-range loads, and bigger, stiffer structures. Think modular semi-monocoque. Aluminum skins, lots of frames and stringers, standardized sections for fast manufacturing and low repair cost. Wide bodies push high structural efficiency by using large composite panels or barrels and integrated load-carrying skins to save fuel on long missions. Aluminum alloys are proven, damage-tolerant, and easy to repair, but lose out on the mass savings composites can deliver for big airframes. Composites give huge strength to weight and shape freedom, but they demand precise manufacturing, different damage detection, and specialized repairs. Modern wide bodies use big composite barrels or large panels laid up with AFP or ATL robots. Narrow bodies mostly use smaller, repeatable metal panels and riveted assemblies. The lightest structure can be the most complex and costly to make. Efficiency on the runway often trades off against shop complexity and supply chain risk. Aluminum shows cracks and corrosion you can spot and drill repair. Composites hide internal delamination and need ultrasonic tap tests and bonded repairs. Wider cabins mean bigger bending moments and thicker floor beams. Wide body designs put more emphasis on global stiffness and distributed skin loads.